Hello students, this is a session in which we are discussing the questions of today's exam, CUET Model Exam Unit 2. നമ്മുടെ സെക്കൻഡ് യൂണിറ്റിലുള്ള ചാപ്റ്റേഴ്സ് ഏതൊക്കെയായിരുന്നു? നമ്മുടെ സർഫസ് കെമിസ്ട്രി ചാപ്റ്റർ, അതുപോലെ തന്നെ നമ്മുടെ പ്യൂരിഫിക്കേഷൻ ആൻഡ് എക്സ്ട്രാക്ഷൻ ഓഫ് മെറ്റൽസ്, അതുപോലെ പി ബ്ലോക്ക്, ഡി ആൻഡ് എഫ് ബ്ലോക്ക് എലമെൻസിൻ്റെ ചാപ്റ്റേഴ്സിൻ്റെ എക്സാം ആയിരുന്നു. അപ്പോൾ പൊതുവെ ക്വസ്റ്റ്യൻസ് ഒക്കെ നിങ്ങൾ കണ്ടു, അനലൈസ് ചെയ്തു. അപ്പോൾ നമുക്ക് അതിൻ്റെ ആൻസേഴ്സ് എന്തൊക്കെയാണെന്ന് ടെസ്റ്റ് ചെയ്ത് നോക്കാം. അപ്പോൾ ഞാൻ അതിൻ്റെ എക്സ്പ്ലനേഷനാണ് ഈ ഒരു സെഷനിലൂടെ ഉദ്ദേശിക്കുന്നത്. ഓക്കെ, അപ്പോൾ നമുക്ക് കെമിസ്ട്രി പാർട്ടിൽ നമ്മുടെ ഫസ്റ്റ് ക്വസ്റ്റിലേക്ക് നമ്മൾ പോവാണ്. ആസ് യു ക്യാൻ സീ ഹിയർ ഇൻ ദ ബോർഡ്. ഓക്കെ, ഞാൻ വായിക്കാം. 50 ml of 1 molar oxalic acid is shaken with 0.5 gram wood charcoal. The final concentration of the solution after adsorption is 0.5 molar. What is the amount of oxalic acid adsorbed per gram of charcoal? This is the question here. അപ്പോൾ നമുക്ക് തന്നിരിക്കുന്നത് നമ്മുടെ കയ്യിൽ ബിഫോർ അഡ്സോപ്ഷൻ എന്തായിരുന്നു? 50 ml 1 molar oxalic acid സൊല്യൂഷൻ ഉണ്ടായിരുന്നു അല്ലേ? 50 ml oxalic acid solution, that is 1 molar solution ആണ് ഉണ്ടായിരുന്നത്. സപ്പോസ് ഒരു ബീക്കർ എടുത്തു. ഇൻ ദിസ് ബീക്കർ വി ഹാവ് 50 ml 1 molar oxalic acid solution. Okay, into this beaker we placed the charcoal piece, that is 0.5 gram wood charcoal. ഇപ്പോൾ ഒരു ചാർക്കോൾ പീസ് ഇതിലേക്ക് ഇൻട്രൊഡ്യൂസ് ചെയ്തിട്ടുണ്ട്. ദാറ്റ് ഈസ് ഓഫ് 0.5 gram. Okay, 0.5 gram charcoal introduce ചെയ്തു. So after adsorption it is given that the concentration of the solution became 0.5 molar. Then what is the amount of oxalic acid adsorbed per gram of charcoal? അങ്ങനെയാണെങ്കിൽ ഇവിടെ 0.5 gram ആണ് നമ്മൾ ആഡ് ചെയ്തത്. So we have to calculate the amount of oxalic acid that is adsorbed per gram of charcoal. If we are taking 1 gram charcoal, what may be the amount of oxalic acid that adsorbed on the surface of that charcoal piece? That is what we have to calculate. Okay, so here it is given that 1 molar solution എന്ന് വെച്ചാൽ എന്താണ്? 1 molar solution means we know 1 molar solution oxalic acid solution means എന്താണ്? ഒരു ലിറ്റർ സൊല്യൂഷനിൽ in 1 liter in or 1000 ml oxalic acid solution contains how much? 1 mole oxalic acid അല്ലേ? അങ്ങനെയാണെങ്കിൽ 50 ml എത്ര മോൾസ് ഉണ്ടാവും? So in 50 ml we can calculate it as 1 by 1000 into 50 mole. Okay, so we will get 0 cancels out and it is 1 by 20. So 0.05 mole, right? 0.05 mole oxalic acid ആണ് നമ്മുടെ ആ ഒരു സൊല്യൂഷനിൽ ഉണ്ടായിരുന്നത്. ഓക്കെ, അങ്ങനെയാണെങ്കിൽ എൻ്റെ മാസ് എത്രയായിരിക്കും? നമ്പർ ഓഫ് മോൾസ് ഉണ്ട്. നമുക്ക് മാസ് ഓഫ് ഓക്സാലിക് ആസിഡ് എന്ന് പറയുന്നത് എത്രയാണ്? മാസ് ഓഫ് ഓക്സാലിക് ആസിഡ് ഈസ് ഈക്വൽ ടു നമുക്കറിയാം നമ്പർ ഓഫ് മോൾസ് ഈസ് ഈക്വൽ ടു മാസ് ഡിവൈഡഡ് ബൈ മോളാർ മാസ്. സോ മാസ് ഈസ് ഈക്വൽ ടു നമ്പർ ഓഫ് മോൾസ് ഇൻറ്റു മോളിക്കുലാർ മാസ്, ദാറ്റ് ഈസ് 0.05 ഇൻറ്റു മോളിക്കുലാർ മാസ് 126, ദാറ്റ് ഈസ് ഈക്വൽ ടു ഹൗ മച്ച്? 126 ഇൻറ്റു 5, ദാറ്റ് ഈസ് ഈക്വൽ ടു so 6.3 gram. 6.3 gram oxalic acid is present. Okay, 6.3 gram. So before adsorption there was 6.3 gram oxalic acid. So after adsorption, that means after adsorption before adsorption 1 molar ആയിരുന്നു. It is given that after adsorption 0.5 molar ആയി എന്ന് വെച്ചാൽ ഇവിടെ മാസ് പകുതിയാവില്ലേ? That is equal to എത്രയായിരിക്കാം? 6.3 divided by 2. 6.3 divided by 2, that is equal to എത്രയാണ്? 3.15, right? 3.15 gram. Okay, 3.15 gram. So it is the oxalic acid present, or the mass of oxalic acid present in the solution after adsorption. So what is the amount of oxalic acid adsorbed? Adsorbed mass is equal to 6.3 minus 3.15, that is equal to 3.15 itself. Actually it is given that 0.5 gram of charcoal was added to the solution, and so in 0.5 gram charcoal it can absorb 3.15 gram oxalic acid. So in 1 gram charcoal can absorb how much? 3.15 into 2, that is equal to 6.3 gram. 6.3 gram charcoal. So our answer option will be this one. 3. Third option will be the answer option. So 6.3 gram oxalic acid molecules can be adsorbed per gram of charcoal. So our answer option is 3. Okay. Now going to the second question. Surface tension of lyophilic salts is, this question is from surface chemistry chapter, lower than that of water, more than that of water, and equal to that of water, none of the above. Surface, നമ്മൾ lyophilic colloids ne കുറിച്ച് പഠിച്ചു അല്ലേ, സർഫസ് ടെൻഷന്റെ കാര്യം. So lyophilic means solvent loving. So it should be having more attractive force towards the solvent, that is water. So surface tension എപ്പോഴും lyophilic colloidsന് dispersed phase ന്റെ surface tension എന്ന് പറയുന്നത് dispersion medium കുറവായിരിക്കണം. So lower than that of water. So answer option will be first option. Okay, option number 1 will be the answer option here. So going to the third question, the coagulation of 10 centimeter cube gold salt is completely prevented by the addition of 0.025 gram of starch into it. The golden number of starch is, golden number, it is the minimum amount of a protective colloid that is required in milligrams to prevent the coagulation of 10 ml gold salt when 1 ml 10% sodium chloride solution is dissolved in it, you know. So what is the gold number of the starch solution? It is given here. It is already given that 10 centimeter cube of gold salt. Okay, so for 10 centimeter cube gold salt, we need 10 centimeter cube gold salt. It is given that we need how much? 0.025 gram of charcoal, right? So in order to calculate the gold number, we have to just convert this 0.025 into milligrams. So that is 0.025 into 1000 milligram. That is equal to how much? 25 milligram. So it is already given here, that is 10 centimeter cube. For 10 centimeter cube gold salt, we have to use 25 milligram starch in order to prevent its coagulation by addition of sodium chloride solution. So here the answer option will be fourth option, that is 25 milligram. Okay, so here it is already given 10 centimeter cube. I forgot it. Okay, so for 10 centimeter cube of gold salt, we need how much? 25 milligram of starch solution, and that is why the golden number will be 25. Okay, so going to the next question, that is our fourth question. It is a match the following type question. First option, list 1 is sorption, then desorption, negative adsorption, extent of adsorption, Langmuir adsorption isotherm. All these are given here. In the right hand side, x by m is equal to k dash p divided by 1 plus kp. Increase with the critical temperature, shaking with the dilute KCl with the blood charcoal, reverse of adsorption, craft temperature. All these are given. So sorption is matching towards, so we know that sorption is the process of simultaneous adsorption and absorption, right? So sorption will be matched with the E, absorption and adsorption. Then what is desorption? Desorption, we know that it is a reverse of adsorption. Okay, what is negative adsorption? For example, here we can use this shaking of potassium chloride, dilute potassium chloride with blood charcoal. That can be considered as a negative adsorption process. Then extent of adsorption can be expressed, extent of adsorption may be extent of adsorption, which is matching with the what? Increase with the critical temperature, increase with that is craft temperature, which is matching here. Increase with the critical temperature. Okay, extent of adsorption, that is matching with our increase with the critical temperature. What is critical temperature? Critical temperature means the temperature at which a gas can be liquefied. So if the critical temperature of a gas is higher, the extent of adsorption will be more. That is how extent of adsorption is matching with the increase in critical temperature, not increase in temperature. Okay, you should be careful. So Langmuir adsorption isotherm is expressed by that expression. So answer option will be 1, that is matches with the E, 1 with V, 3 or 4. 2 will be matching with the D. Okay, both are same. Negative adsorption, C. Extent of adsorption, that is extent of adsorption is matching with the B. So our answer option will be third option, and last one, absorption will be matching with, Langmuir adsorption will be matching with the A. So our answer option is 3 for the question number 4. Next, going to the fifth question. The golden number of gelatin, hemoglobin and sodium acetate are 0.005, 0.05 and 0.7 respectively. The protective action will be in the order. We know that the protecting power is related to golden number. How? Smaller the gold number, higher will be the protecting power. Okay, so as the gelatin is having 0.005, then here hemoglobin is having 0.05, and sodium acetate is having 0.07. So this is also in the increasing order of these values, and so the second option will be the answer option here. Okay, second option, gelatin, hemoglobin, sodium acetate will have the least gold protecting power, because sodium acetate is having the highest gold number. Gelatin is having a least value for gold number, and that is why it is the protective colloid having high protecting power. Okay, then going to the sixth question. Colloids can be purified by which among the following are the purification methods of colloids? Peptization, coagulation, dialysis, Bredig-Sark method. Okay, Bredig-Sark method. So which is the option for purification? It is dialysis. We know that peptization and coagulation, then Bredig-Sark method, all these are preparation methods of colloids, and that is how dialysis came as the answer option. Okay, next seventh question. Which of the following is wrongly matched? Gemstones, solid soul എന്ന് പറഞ്ഞിരിക്കുന്നു. അതുപോലെ തന്നെ സെക്കൻഡ് ഓപ്ഷൻ പറഞ്ഞിരിക്കുന്നത് സെൽ ഫ്ലൂയിഡ് സോൾ എന്ന് പറഞ്ഞിട്ടുണ്ട്. സ്മോക്ക് ഈസ് ആൻ എക്സാമ്പിൾ ഓഫ് എയറോസോൾ എന്ന് പറയുന്നു. മിൽക്ക് ഈസ് ആൻ എക്സാമ്പിൾ ഓഫ് ഫോം എന്ന് പറഞ്ഞിരിക്കുകയാണ്. സോ you know this is the incorrectly matched pair. Milk is an example of emulsion. Okay, milk is an example of emulsion. So our answer option will be 4. Okay, for seventh question. So going to eighth question, the volume of gases, that is ammonia, carbon dioxide, methane, adsorbed by 1 gram of charcoal at 298 Kelvin R. Okay, so here we can say that third option will be the answer option. Ammonia, carbon dioxide, and methane. So here this order is based on their liquefiability. Ammonia is the most liquefiable gas among these, then carbon dioxide, and the least liquefiable gas is which one? Methane gas. This can be considered based on explained based on the ability to form intermolecular hydrogen bondings or critical temperature. If you know, ammonia is having the critical temperature 132 degrees Celsius, carbon dioxide 31.2 degrees Celsius, methane is minus 82.3 degrees Celsius. So third option will be the answer option here. Okay, now ninth question, going to ninth question. IISER-5 converts. We know IISER-5 is an example of zeolite, sieve of molecular porosity 5. It is an example of shape selective catalyst. So it can convert alcohols into petrol. That is the first option. That is our answer option here. You know, IISER-5 is the catalyst which is used for many petrochemical activities. It is an example for a shape selective catalyst also. Okay. Then going to 10th question. That is, at the isoelectric point, colloidal particles become neutral. Colloidal particles neither move towards either electrodes, and no conductance takes place. And the fourth option is 1, 2, and 3 are correct. So which is the answer option here? Fourth option. So all these are correct. At isoelectric points, there may not be any movement of conductance takes place, and the colloidal particles become neutral. That is also correct. Colloidal particles neither move towards either of the electrodes at isoelectric point. So our answer option will be fourth option. Okay. Then going to 11th question. The solution of rubber in benzene is an example of. We know multimolecular, macromolecular, associated, and lyophilic colloid. This is a simple example. It is example for macromolecular colloid, no doubts. Okay, so rubber in benzene is an example of macromolecular colloid. So going to 12th question, gelatin is mostly used in making ice creams in order to what? Prevent forming the colloidal solution, enrich the fragrance, prevent crystallization, modify the taste. Which purpose? Which is the purpose for using gelatin in ice creams? Yes, it prevents the crystallization. It can be used as a stabilizer. It can be used as an emulsifier or stabilizer for ice creams. It is a protective colloid. Okay, so it is used to prevent the crystallization of ice cream. So third option is the answer option for 12th question. Going to the 13th question, colloidal solutions commonly used for intramuscular injection is, that is colloidal gold salt, colloidal silver, colloidal antimony, colloidal sulfur. Here the answer is, you know, it is colloidal gold, that is used for intramuscular injection, and colloidal antimony is used for the disease Kala Azar. That is another question. which can be expected from this area. Okay, so colloidal silver can be used as a mineral supplement for our body. Also, colloidal sulfur is used in skin ointments, etc. Okay, so these are the uses of some colloids. So here the answer option is colloidal gold that can be used for intramuscular injection. Okay. Next, 14th question. Going to 14th question. Cod liver oil is an example of oil in water type emulsion, water in oil type emulsion, aerosol and gel. Which is the answer option here? Yes, that is cod liver oil is an example of water in oil type emulsion. Here dispersed phase is water and dispersion medium will be oil or fat. Okay. Now, going to 15th question. Which of the following metal is obtained by leaching its ore with a dilute cyanide solution? This question is from metallurgy, purification and extraction of metals. Okay, so which of the following metal is obtained by leaching its ore with a dilute cyanide solution? Yes, here it is given aluminium, copper, zinc, silver. Okay, you can see among these metals we can say that aluminium and silver aluminium can also be extracted by leaching process, but there we will use sodium hydroxide. I think you can remember it. But silver is the metal, or silver, gold, etc. Such metals can be purified by cyanide process, that is leaching by sodium cyanide or potassium cyanide can be used, and that is how answer of this question becomes fourth option. Okay. Next, going to our 16th question. The most commonly used method for the concentration of oxide and carbonate ores is, which is the method used for concentration of oxide ore and carbonate. You know what is concentration of ore? Gravity process or levitation, froth flotation, magnetic separation, leaching. Which is the method used for the separation of carbonate ores? Yes, it is gravity process or levitation. It is based on density difference between ore particles and impurities. Okay, so gravity separation. So going to the 17th question. Levitation is based on the difference in dash ore particles and impurities. Dash of ore particles and impurities. Just told you that this process is based on the difference in density of ore particles and impurities. No doubt here the answer option will be second option for our 17th question. Okay. Now, next, going to 18th question. The chemical reagent which is used for leaching of gold and silver ore is gold and silver ore. Which is the reagent used? I think all these three questions are interrelated. So here the answer option, you know, gold and silver ore can be leaching, separated by leaching by using what? Sodium hydroxide, potassium cyanide, potassium cyanate, sodium sulfate. Which one will be the answer option? Yes, no doubt it is potassium cyanide, or sodium cyanide can also be given here. Okay, also be considered. So our 18th question is having second option as the answer option. Next is 19th question. The substance used as an activator in froth flotation processes. Froth flotation, you know, here we will convert this is used for the concentration of ore. Here the activator, potassium ethyl xanthate, sodium cyanide, pine oil, copper sulfate, etc. are given in the options, and 3, that is copper sulfate can be used as an activator. Activator is used for enhancing the interaction of these collectors. Collector molecules, collector particles are there. That is potassium ethyl xanthate, sodium cyanide, pine oil, etc. can be used as collectors, you know. And copper sulfate can be used for enhancing the interaction between these collectors and mineral particles. Okay, so copper sulfate is using as an activator in which process? Froth flotation process. So our answer option, that is for 19th question, it is option number 3. Going to 20th question. Which of the following is not a basic flux? Basic flux and acidic flux, I think you know. Basic flux are used for what? Removing basic impurities. Acidic flux can be used for acidic impurities. Okay, these can react with the acidic ion or basic ion respectively. Here silicon dioxide, calcium carbonate, calcium oxide, magnesium oxide. You know that metal carbonate, metal oxide, calcium oxide and magnesium oxide are having basic characters, and this is used for removal of acidic impurities. At the same time, silicon dioxide is acidic in nature, and that is why it can be used as it is not used as an acidic flux. Okay, so calcium carbonate, calcium oxide, magnesium oxide all can be used as acidic flux, but silicon dioxide, as it is acidic, it can be used as basic flux. So no, it is not a basic flux, it is an acidic flux. Okay, so acidic flux, all others are basic fluxes. Then, which of the following, going to 20th question, which of the 21st question, which of the following is not a method for concentration of ore or concentration? Gravity separation, hydraulic washing, magnetic separation and smelting, which is not a method for the concentration of ore. Okay, that is the answer, the question which is asked there. What is gravity separation, hydraulic washing, magnetic separation? All you know, these three are meant for concentration of ore. At the same time, smelting, that is, smelting means it is a process of getting pure metal by treating the metal compound at high temperature, melting process. Okay, so smelting cannot be used for, and that is not meant for enrichment or concentration of ore, but all others are used for concentration of ore. Okay, so here the answer option is 4. Next, going to 22nd question, this is a matching type of question, you know. Identify the mismatched ore. Okay, ores and names of ores and those metals are given. Cerussite, first one, cerussite, as you can see here, that is carbonate ore of lead, it is given here. Calamine, carbonate ore of zinc, that is also correct. All these two are correct, 1 and 2 are correct. Okay, limonite is, it is given that it is oxide of copper, but it is actually oxide of iron, hydrated iron oxide. Actually, this compound present in our soil is giving color to soil. Okay. Then ozerite, that is carbonate of copper. So our answer option will be limonite. That is the third option. That is the answer option for 22nd question. Okay. Next, going to 23rd question, which does not represent the correct method. So titanium chloride, you can, I think you can see here it is titanium chloride and magnesium will give titanium plus 2 MgCl2. The process given it is Kroll process. We have to choose the incorrectly matched pair. Okay. The first option is Kroll process. I think you know that about that process. Then nickel carbonate, that is giving nickel plus carbon monoxide. That is called the Mons process. Nickel carbonate on decomposition. It will give a nickel and carbon monoxide. That is Mons process. That is also correct option. Then third one, silver carbonate gives silver plus carbon dioxide plus half O2. It is given that it is a Van Arkel process. I think there is some problem, right? Usually Van Arkel process, as you all know, it is used for iodide ores, metal iodides. Okay, that is given in the fourth option. You can see here. Zirconium iodide is giving zirconium plus iodine. That is Van Arkel process actually. So here the third option is incorrect. Our answer option will be the third option. Okay, so third option is the answer option. Because Van Arkel process is not used for carbonates. Carbonates are decomposed into carbon dioxide, metal, etc. It is heating of carbonates at a high temperature. You can say roasting, then calcination, roasting, all these processes you know. So here Van Arkel process is mainly meant for iodide, and so fourth option is the correct one, but third option will be incorrect. So answer option will be third, as there we need the incorrectly matched or doesn't represent the correct method. Okay, so answer option is 3. I think it is clear to you. Then going to the 24th question. In the equation 4m plus 8cn minus plus 2h2o plus O2 gives 4mnCn twice minus plus OH, 4OH. Identify the metal M. Okay, here it is given that a metal, that is M, that is treated with a cyanide, sodium cyanide or potassium cyanide, and we can separate that metal in pure form. Metal cyanide can be obtained, and this method is mainly meant for, here M is mainly meant for which one? You know, that is already we told about this process in the 18th question. I think it is chemical reagent for leaching of gold. Okay, so cyanide process, that is gold. Cyanide, by using cyanide, that is leaching using cyanide, that is gold. Aluminium, iron, gold, zinc. Gold is the metal here, that is extracted using this method. So given metal is gold, that is our answer option. Third option is the answer here. Okay, next one. 25th question. In Ellingham diagram, the slope of the curve of the formation of a metal oxide is, you know, metal oxide, the slope of the curve in Ellingham diagram for the formation of metal oxide. Okay, for carbon monoxide, you know, it is downward. For carbon dioxide, it is a straight line parallel to the temperature axis, and for metal oxide it will always be upward, right? So mostly it will be positive, having positive slope. You already know that, I think. So for in Ellingham diagram, it is the main application of Ellingham diagram. We can see that the slope of the lines will always be positive, or mostly positive for almost all metals in Ellingham diagram. Okay, so our answer option will be the first option for 25th question. Then going to 26th, question number 26. Chromatographic method is based on the principle that different components of a mixture are differently adsorbed on an adsorbent. Actually, that is the answer option here. No need of any other options. And different components of a mixture are differently adsorbed on an adsorbent. Okay. Then the remaining options are same components of mixture are differently adsorbed on an adsorbent. Different components of a mixture are, it is not differently, so equally adsorbed on an adsorbent. One more option is needed there. It is not given in that board. Okay. Then the fourth option is none of the above. None of the above. So answer option will be first one. That means different components of a mixture are differently adsorbed on an adsorbent. The rate of adsorption of different colored substances in a mixture is different. That is the principle of chromatographic method for the separation of colored substances from that solution. Okay, so for 26th question, the option number 1 will be the answer option. Okay, going to 27th question. Delta G formation versus temperature. Delta H formation gives the free energy for the formation versus temperature. A plot in Ellingham diagram slopes downwards for the reaction. Which one? I already told you just before while discussing the question number 25. Okay, so which is the answer option here? Magnesium oxide, formation of magnesium oxide, formation of silver oxide, formation of carbon monoxide, formation of carbon dioxide. Which one? Yes, it is formation of carbon monoxide. So here in this case, the plot of Ellingham plot, delta formation, delta G0 versus T plot in Ellingham diagram slopes downward for the reaction. How? Because entropy is becoming more, right? Here all are solid and the gas are reacting to form a gaseous product, and entropy is increasing, and that is why delta G value is becoming negative. So slope that is moving downward, we know. So answer option will be 3. Okay. Now going to 28th question. Which of the following compounds does not exist? Which of the following compounds? NCl5, ASF5, ISBCl5, PF5. I think you can see it in the board. NCl5, ASF5, SbCl5, PF5. Which is a chapter? P block, yes. So nitrogen pentachloride, is it possible? No, because there is no vacant d orbitals for nitrogen, and that is why NCl5 is not possible. So here our answer option becomes first option. Okay, it is not possible. All others can be possible. Okay, next. Going to the 29th question. The gases produced in the reaction PbNO3 twice gives dash and NH4NO3. Lead nitrate and ammonium nitrate are undergoing thermal decomposition. The gases produced in these reactions are, no doubt this is also from P block elements chapter. Okay, so here the gases PbNO3 twice will give NO2 gas, PbO plus NO2, PbO comma NO2. These are the products obtained here. And also in the case of ammonium nitrate, there we will get what? H2O and N2O. H2O and N2O. These are the products. So our answer option will be NO2 and N2O. NO2 and N2O. NO2 and N2O. Which is the option? Fourth option. Yes, this is the answer option here. Fourth option is the answer option for 29th question. Okay. Going to 30th question. That is xenon tetrafluoride on partial hydrolysis produces. On partial hydrolysis of xenon tetrafluoride, it is the same reaction is given in your NCERT textbook. Okay, XeF4 on partial hydrolysis we will get the products HF and XeOF2. HF and XeOF2. Here the answer option is second one, XeOF2. So that is the product. Here HF is not given. In some questions, the partial hydrolysis of xenon tetrafluoride may produce, both of these two compounds may also be given. Here it is given only XeOF2, xenon oxyfluoxetine fluoride. So answer option is second option. Okay, the same equation is in your NCERT textbook. Okay, so going to 31st question. SS bond is present in which acid? Here H2SO3, H2S2O8, H2SO5, H2S2O3 and H2S2O6 are given. Among these acids, oxo acids of sulfur are given. Among these oxo acids of sulfur, which one is having the SS bond? That is, we have to find out. Okay. So before finding the answer of this question, we have to draw the structures of all these acids. Okay. So I am going to draw H2SO3. H2SO3. How can you draw easily? We need the basic structure, that is the fundamental structure of all these oxo acids. S double bond OH. Okay, S double bond OH. Now I have the formula H2SO3 here. From this I need what are the additional components which is to be added into this structure. So I am going to minus this structure from this one. So SO2H is minus here. Suppose simple mathematics. So OH, HO is added to this. So we need an HO. 2 electrons will be there in sulfur. So this is the structure of H2SO3. Is there any SS bonds? No. It is not our answer option. Okay. Now going to the next acid, that is our H2S2OH. H2S2OH. Here also I am starting with S double bond OH. Okay, H2S2OH. Here 2 sulfur atoms are there, so we need one more structure like this, OH. Okay, now how many sulfur atoms are here? S2, H2 and 1, 2, 3, 4. 4 oxygen atoms. Minusing these. So we will get to what? O4. Okay, 4 oxygen is to be added to this. So I am going to add the 4 oxygen atoms. Here double bond oxygen, here double bond oxygen, single bond oxygen, and sulfur. So this is our H2S2OH. This is peroxo disulfuric acid. Okay, peroxo disulfuric acid, Marshall's acid, right? So it is also not having any SS bonds, right? No SS bonds present here. No SS bond. H2S2OH is not our answer option. Now H2SO5. H2SO5 I am taking. Starting with the fundamental structure, that is S double bond OH. Here only one sulfur atom. So SO2H is by minusing 3 oxygen, then 1 hydrogen needed here, right? So one OH bond is necessary, and then 2 oxygen atoms are also there. So I am giving 2 double bond oxygen and here oxygen and an OH group into this oxygen atom. So this will be our structure of peroxo monosulfuric acid. It is also not having any SS bonds. Okay, no SS bonds. This is also not our answer option. Now we are looking into the fourth option. Let us find it out. That is H2S2O3 and H2S2O6. 2 acids are given there. H2S2O3. I am taking S double bond OH. As we all know, there is 2 sulfur atoms. I think one more structure is necessary here. Okay. Now minusing this S2 oxygen 4. So there is a problem. What? We cannot minus 4 oxygen atoms from 3 oxygen. So you should remember, for this acid we need only one structure. So we have to minus only the fundamental structure from here, SO2H. Okay, so oxygen, sulfur, HSO. That is S here OH. So this is the structure of our H2S2O3 acid. So this is having, as you can see here, this is having an SS bond, right? The first acid is having an SS bond. So I am placing this one here. Going to the second acid, H2S2O6. 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 Okay. Now, starting with the fundamental structure is double bond to OH, and here two sulfur atoms are there. So, two fundamental structures, H2S2O8. So, H2S2O4 is minusing here, and we will get O2. Okay, O2. So, this is a double bond oxygen. Here it is a double bond oxygen, and two sulfur atoms can be connected, because both of these two oxygen atoms are to be given equally for these two sulfur atoms. Okay, and that is why I took two double bond oxygen atoms here, and only then it will become balanced. And here also we can see an SS bond, right? So, our answer option, it is clear now. Answer option is fourth option, that is H2S2O3 and H2S2O8, O6. These are the two acids in which SS bonds are present. So, answer option for our 31st question is answer option 4. I think you got the idea how to draw the structures of oxo acids of sulfuric acid easily. Okay, this is not a chemistry way of drawing the structures, I know. I am giving you a short, simple method to draw the structures of all the oxo acids of sulfur. Okay, I think it is clear to you. So, that is here answer option is fourth option. Okay, now going to 32nd question. Among the trihalides of nitrogen, which one is the most basic? Trihalides are given here. NF3, a lone pair, NCl3, a lone pair, Ni3, a lone pair, then NBr3, a lone pair. In order to show a basic character, our acids, our compound should be able to donate the lone pairs. The ability to donate lone pair depends on how strongly it is attracting towards these compounds. As here you can see fluorine atoms which are more electronegative. Will they allow the release of this electron from these compounds? Never. So, as here, iodine is the one that is having the least electronegativity. It can allow the electronic donation from that nitrogen atom, and that is how it is acting as a Lewis base. So, Ni3 is the compound which is having highest Lewis base character. So, answer of our 32nd question is 3. Okay, this is most basic. Next. Going to 32nd question is, answer of our 32nd question is 3. Now going to 33rd question, that is, among the following, which is the strongest oxidizing agent? We know fluorine, chlorine, bromine, iodine. Which is the strongest oxidizing agent? No doubts, that is fluorine. Okay. Now going to 34th question. Carose acid is, we know carose acid, H2SO3, H2S2O5, H3S2O5, H2SO5, H2S2O8. Here, H2SO3 is, we know, sulfurous acid. H3S2O5 is not existing, I don't think. H2SO5, that is called H2SO5, that is peroxomonosulfuric acid, and it is also known as carose acid. We know this is peroxodisulfuric acid, it is known as Marshall's acid. It is carose acid. So, our answer option is third option. That is for 34th question. Okay. Now, going to 35. Here some compounds and their properties are given. We have to match them suitably. First one is XeF2, xenon fluoride. Xenon fluoride, we know that it is isostructural with ICl4 minus sp3d2 hybridization. Then XeF4, it is XeF4, B is explosive pyramidal isostructural with OXO3. Anything may be the options. Here we can find the answer option simply by using the hybridizations. Okay. So first of all, you have to know the hybridization in XeF2. You know Xe, atomic structure, electronic configuration Xe ending with the NS2NP6, right? This is the ending configuration for xenon. That means there are 2 electrons in the S subshell and 6 electrons in the P subshell, right? S, P. And also there is vacant d orbitals. Okay. So, in order to form XeF2, how many electrons should be involved? This electron should be excited from here and towards here. Okay, so these two electrons will be shared between two fluorine atoms, and so sp3 that is our option, that is sp3. Okay, sp3, then one d orbital is also involved, right? So hybridization here it is sp3. So for XeF2 we can match sp3 hybridization where it is given E. So our matching option for XeF2 will be E. It is having sp3d hybridization. It is also isostructural with the KrF2, you know. XeF2, KrF2, same format. Okay. Now XeF4. Think, in order to form XeF4, 4 electrons are needed. So this electron will be shifted towards a d orbital. So 4 electrons are able to form bonding now. sp3 D2 hybridization, no doubt. sp3 D2 hybridization. Here A and D options are having sp3 D2 hybridization. So XeF4, isostructural with the ICl4 minus. That is also correct. So we can match it with this one. That is XeF4 will be matching with the A. Okay. Now XeF6. XeF6. In order to form 6 bonds, we need 6 electrons. This electron is shifting towards here. 6 electrons are present, right? So sp3d3. sp3d3 hybridization. It is given in C option. Okay. XeF6 is matching with the distorted octahedral shape, and sp3d3 hybridization. The third one will be matching towards C. And the fourth one is XeO3. XeO3 means we need how many electrons? 6 electrons. 1, 2, 3, 4, 5, 6 electrons are here. But is this the hybridization possible? No. Oxygen atom, each oxygen atom need how many electrons? 2 electrons. So there is no shifting. So electrons will be like this, and 3 oxygen atom will be sharing all these 3 electrons in the p subshell. So sp hybridization will be there, right? sp3 hybridization will be there. So our fourth one will be matching towards sp3 hybridization. Okay, because each 2 electrons are bonded with each oxygen atom. Because oxygen need 2 electrons, the structure will be xenon, this one, double bond oxygen. So 2 electrons are required and sp3 hybridization, and XeOI for the remaining matching will be which one? That is our option D. That is colorless volatile liquid square pyramidal sp3d2 hybridization. sp3d2 hybridization. How? sp3d2 XeOF4. Okay. So in order to get 4 fluorine atoms, we need 4 electrons. Single electrons are required, and 2 d orbitals are required, and these 2 electrons will be shared with the oxygen atom. XeOF4, 1, 2, 3, 4. These are for fluorine atoms, and this one is for oxygen. sp3d2 hybridization. sp3d2 hybridization. I think it is clear to you. So which is the answer option for this question? No doubt it is our fourth option. Okay, fourth option is the answer option here for the 35th question. Okay, now going to 36. That is, ammonia gas can be collected by downward displacement of which one? Water, air, mercury, acid. We know that ammonia is very, very lighter than air, and that is why it can be extracted by downward displacement of air. Okay, because it is lighter than air, so air will be downward. Ammonia gas will be upward, right? So as it is lighter than air, it will be moving upward, displacing air downward. So in that sense, we can say that downward displacement of air. Now, going to 37th question. Which of the following is not an explosive? Cyanamide, dynamite, TNT, TNG. We know cyanamide is the answer option here, no doubt. It is not an explosive. Dynamite, you know, explosive. TNT, trinitrotoluene, then trinitroglycerin. These are explosive compounds, and cyanamide is the answer option for our 37th question, option number 1. Okay, going to question number 38. The correct decreasing order of acidic character of the following oxides of manganese are. Manganese oxide Mn2O7, MnO2, Mn2O3, Mn3O4 all are given. MnO all are given, and among these the correct decreasing order of acidic character. You know, these are metal oxides. Usually we may think that metal oxides are basic in nature, right, or amphoterary, but it is given that acidic character. One thing you have to remember, that is the metal oxide in which the metal is in highest oxidation state, that oxide will be having more acidic character. That means electron accepting tendency will be there. So we have to calculate the oxidation states of manganese in all these oxides. That is the first thing you have to do in order to find the answer of this question. So I am going to give you the values of oxidation numbers of these metal atoms for time consuming, okay, for time saving. So +7, +7, +7, here it is +4, and it is +3. Then Mn3O4, this is a mixed oxide. It may contain Mn2O3 and MnO2. Okay, and MnO2 is having +2 oxidation state. So I think it is enough from the first option. While writing the values of oxidation states of manganese, it is clear that it is the answer option, right? So manganese in which here in other options we can see Mn2O, here +7, Mn2O7, that is +7, Mn3O4, it is a mixed oxide, then MnO2 is +4. So this is incorrect, it is clear, I think. MnO, that is not also correct. A fourth option, MnO, that is not correct. So in the first option here we can see that manganese is in highest oxidation state of +7, and on decreasing the value of oxidation states of manganese central atom, the acidic nature will also be decreasing downward, decreasing. So option 1 will be the answer option. I think you got the idea. Once again I am repeating, the metal oxide in which the metal atom is highest oxidation state, it will be more acidic than that in the lower oxidation state, because it can accept more electrons. Electron acceptor, it can act as an electron acceptor. Okay, that is how it is behaving as an acid, Lewis acid. Okay, so 38th question option number 1 is the answer. Okay, now for 39th question, which of the following pair is an actinide? D and F block. Okay, which of the following pairs is an actinide? PM and YB. PM and YB. I think I need a periodic table to justify the answer. Okay, you also need to refer your periodic table. Okay, so it is given PM and YB. PM means promethium and ytterbium. We can see both of these two elements in the lanthanoid series, PM and ytterbium. Where is ytterbium? No, yes, ytterbium, it is here 70 atomic number. So both are lanthanoids. We need actinide series. Okay. Good. Gadolinium and europium, GD and EU. GD and EU. It is GD. Where GD? GD and EU. Europium. Both of these two elements are in the lanthanoid series. Then curium and samarium. Curium and samarium. CM here you can see CM and then next one is SM. Where it is? SEM. SM is in lanthanoid series. Both series. So third option is not correct. Then cerium and protactinium. Cerium and cerium. We know cerium. Where is cerium? CM. Not cerium, sorry. Not cerium, curium. Okay. CM and protactinium. Protactinium, that is PA. Both of these two elements are in actinide series. So our answer option will be, no doubt, it is fourth option. Okay. Fourth option. Next. Going to 40th question. Among the following series of transition metal ions, the one where all the metal ions have a 3D2 configuration is Ti3+, V2+, Cr3+, Mn4+. All these ions are given here in different oxidation states. So the group in which there is the metal ions have a 3D configuration, 3D2 configuration. So in order to answer this question, for the explanation purpose, I need the electronic configuration of these elements. That is, the main elements are titanium, vanadium, chromium and manganese. Okay, I'm going to write the valence electronic configuration of these metals. First one, titanium. Titanium, it is 3s2, 3p6, 4s2 and 3d2. Okay, now vanadium, that is 3s2, 3p6, 4s2 and 3d3. Next is chromium, 3s2, 3p6, 4s1 and 3d5. Next is manganese, 3s2, 3p6, 4s2 and 3d5. Now we have to ionize these metals. Okay, Ta3+. The question is, among the following series of transition metal ions, the one where all metal ions have a 3d2 configuration. All should have a 3d2 configuration, ending configuration 3d2. Which is the correct option? Okay, we can calculate or we can find it out. Ta3+. Here 3 plus means 3 electrons are lost. The first 2 electrons will be lost from this 4s2. Okay, and 1 electron will be from 3d2. So 3d1 will be ending there. So this is not our answer option, right? Because titanium 3 plus is not having 3d2 configuration. So this option can be avoided because we need the set or series of transition metal ions. So this series is not satisfying the condition which is given. Okay, now Ta plus means the electron from 4s is lost, 1 electron. So remaining 1 electron is there, 4s1 3d2. That is not correct. Okay, now Ta plus 3d2 configuration is still there. Okay, so there may not be 3d2, right? 4s2 will be converted into 4s1 and the remaining 1 electron will be shifted towards that 3d2 and 3d3 will be there. Okay, so this one cannot also be considered. Third option, Ta4+. Ta4+ means all the 4 electrons will be lost and the remaining will be 3p6 and this can also be avoided. Next, Ta2+. Ta2+ means these 2 electrons are lost, so the 3d2 will be remaining there. Then V3+ means here 2 electrons from 4s and 1 electron from 3d will be lost and remaining will be 2 electrons in the 3d. So there may be 3d2. Next, Cr4+. 4+ means 1 electron from S and 1 electron from 4 electrons, 1 electron from S and 3 electrons from D5 will be lost. In D5, 3 electrons lost, remaining will be 2 electrons and there may be 3d2 configuration. That is also okay. Mn5 plus 5. Here we know, plus in order to, total 7 electrons are there in 4s and 3d5. 5 electrons lost, so remaining will be 2 electrons. Out of 7 electrons, 5 will be lost and remaining will be 2 electrons and those 2 electrons will be in D, 3d2. So our answer option will be 4th option. So for solving this question, we need the electronic configuration of these metals. Okay, that is the way to find the answer option easily, I think. Okay, that is the answer option for 40th question. Okay. Then 41st question. In aqueous solution, Eu2 plus acts as in aqueous solution. Eu2 means we know europium is the metal, right? Okay, so generally europium, for these lanthanoids, the stable oxidation state we know it is +3. Eu +3 is preferred. In order to form +3, it should remove one more electron from Eu2+. Okay, so as it is removing an electron, it can act as a reducing agent. So our second option will be the answer option, no doubt. So for 41st question, answer option is 2, reducing agent. Next up. 42. Arrange Ce3+, La3+, Pm3+, and Yb3+ in the increasing order of their ionic radii. Ionic radii, that is cerium, then lanthanum, then promethium, then ytterbium. All these elements are coming under lambdanoid series, and as these are having plus 3 charges, charges are plus 3, but their sizes will be increasing in order. That means the least one will be ytterbium. So using the periodic table, let us analyze the position of these metals. Which are the metals here? They are ytterbium. Why? Where it is? Cerium. Cerium is here. Cerium. Then lanthanum. Lanthanum. Where it is? Where is it? Lanthanum. Lanthanum here. Promethium. PM. Okay. And then ytterbium is here. You know lambdanoid contraction. Lambdanoid contraction. So it is clear that it is here the ion which is having the largest ionic size will be of lanthanum. Okay, lanthanum here it is in the first element. First element of lambdanoid is, it is lanthanum, and that will be having the highest atomic size. And due to lambdanoid contraction, other ions will be having decrease in their sizes. And so we can write the elements in the order, that is ytterbium, promethium, cerium and lanthanum ions. This is the order of ionic size of these elements. Okay. Towards rightward, the order is in the reverse one, that is lanthanum is given the last, but it is having the largest size. It can also be written as La3 plus, then Ce3 plus, then Pm3 plus, and then Yb3 plus. This is the order in the periodic table, and this is why it is decreasing. That is due to lanthanide contraction, and so it is the order. First option will be the answer option for 42nd question. Okay. Now going to 43rd question, that is, in which of the following pairs are both the ions colored in aqueous solution? We know in order to give color, there must be an unpaired electron. Okay. So scandium 3 plus, cobalt 2 plus, Ni2 plus, Cu plus, Ni2 plus, Ti3 plus, and scandium 3 plus, Ti3 plus, etc. are given. Also their atomic numbers are also given here in this question. So by writing the electronic configuration, by analyzing the valence electronic configuration, we can find which pair contains both the ions which can give colors in solutions. Okay, so scandium, the first one is scandium. I am going to write the electronic configuration of these elements. Scandium, it is 3d1 4s2. Okay, and also titanium, that is 3d2 4s2. Then nickel, that is 3d8 4s2, and so cobalt, that is 3d7 4s2. Here it is given how I got the electronic configuration after atomic number 18. You can write. Okay, so scandium 3 plus. Scandium 3 plus means here in scandium total 3 electrons are there. All the 3 electrons are lost, and the remaining core will be having paired electrons only. So it is not colored. Scandium 3 plus is not colored, and so first option can be avoided. Now CO2 plus. CO2 plus, we know if 2 electrons are lost, its 3d orbital may contain how many electrons? 2 electrons may be there. So total 7 electrons are there. Let me draw the orbital also. 3d, here it is 4s, 3d1 4s2. Okay, here it is 3d2, no, 3d2 4s2. Here it is 3d8, 1 2 3 4 5 6 7 8, and 4s2. Now 3d7, 1 2 3 4 5 6 7, and 4s2. So here cobalt CO2 plus means 2 electrons lost and 3 electrons are there. It can exhibit color, unpaired electrons are there, but as scandium is not satisfying the condition, it cannot, okay, because 3 plus 3 electrons will be lost. So it cannot give color, so first option is eliminated. And then going to second option, Na2 plus. Na2 plus means If 2 electrons lost, 2 electrons are existing as unpaired, and Na2 plus can exhibit color. Cu plus, copper is also needed, right? 3D10 4s1. Okay, copper, that is missing here. Cu 3D10 4s1. 3D10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 4s1. 1. Okay. So Cu plus means one electron is lost and others are existing as paired. So this can also be eliminated. This one can also be eliminated because single electron should be there in order to exhibit a color. Okay. Now, but Cu2 plus can exhibit a color because there may be a single electron, unpaired electron. Na2 plus means 2 electrons lost and 2 electrons are existing as unpaired. Na2 plus can exhibit a color. Ta3 plus means 2 electrons from here and 1 electron from here, and so there is a single electron remaining, and so this pair can exhibit a color in solution. Sc3 plus means all the 3 electrons lost, no color. So answer option is 3. I think you got the idea how to find the answer of this question. Okay, so here the answer option is 3 for 43rd question. Now going to question number 44. White phosphorus is kept under. We know white phosphorus is very reactive. This question is from P block, and it can be kept under water. Okay, so answer option will be 1. Now, chromium, CrO-Cr bond in Cr2O7 2 minus. CrO-Cr O. This is 126 degree. Okay, the bond angle here it is 126 degree. Answer option is 4. This is a fact. Okay, so not can be calculated. This is the diagram, same diagram is given in your textbook also, and you can refer. The answer option is 126 degree. So answer option of 45 question is 126 degree, that is option number 4. Now going to 46th question. Which of the following oxides of chromium is amphoteric in nature? The same thing is given in your NCERT textbook. Chromium oxide is, we know, CrO is basic. Cr2O3 is amphoteric. Here answer option is second option. The same thing it is given in your NCERT text. Okay, CrO3 is acidic and CrO5 is highly unstable, and here the answer option is second option. So 46th question answer is second option. 47th question. The hardest lanthanide with the highest melting point is, that is a fact, cerium, praseodymium and neodymium, then samarium, samarium. That is, samarium is the answer option. Okay, 1072 degrees Celsius is the melting point of this metal, and the answer option is fourth option. Okay. Now going to 48th question. Arrange the following ions in the order of their magnetic moments. So in order to exhibit magnetic moments, we need number of electrons. Okay. So remaining electrons are there, should be there. So how many electrons are remaining in that ion? That is, we have to calculate. So using that data, we can find the order of magnetic moments. So the ions given here are V4 plus, that is vanadium, then manganese, then iron, then nickel. These are the metals, we know. Configurations are 3D3 4s2, then second one, manganese is 3D5 4s2, and iron, it is 3D6 4s2, and then nickel, that is 3D8 4s2. So after removal of these electrons, we can identify the answer. V4 plus means what? 2 electrons from S and 2 electron from D. So remaining will be 1 electron. So here we can see 1 unpaired electron, 1 electron. In Mn4 plus means 2 from 4s and 2 from 3D. So total 5 electrons in 3D, 2 electrons lost, remaining will be 3 electrons. 3 electrons are there in d orbital. Fe3 plus means 2 electrons from s and 4s and 1 electron from 3d. So 5 electrons are there. 5 unpaired electrons are there. And here you can see Ni2 plus 2 electrons from 4s. So remaining will be 5, then 2 electrons in d subshell, unpaired electrons. So we can arrange them in the increasing order of number of unpaired electrons, and among these plus 3, Fe3 plus is having 5 electrons, it may have the highest magnetic moment. So third one, that is this option or this option can be the answer option. Then 3 is the next number, that is Mn4 plus, that is second. So here it is second, there 4 is given. So answer option will be 3. This can be avoided. So all these 3 options can be avoided, and the third option can be the answer option. Iron 5 electrons, then manganese 3 electrons, then fourth one nickel 2 electron, and the first one V4 plus, that is the last one, least magnetic moment. So answer option for our 48th question is option number 3. Now going to 49th question. Match the following. Thorium, uranium, neptunium, plutonium, americium. These are the metals given, elements given. We have to match them suitably with the properties given in the right hand side. Okay. So in order to find the answer again, we need the electronic configuration of these metals. Okay, electronic configuration of these metals I am writing. Here it is 6d2 and 7s2. 5 of 3, 6d1, 7s2. Neptunium, that is 5f4, 6d1, 7s2. Then plutonium 5f6, 7s2. And then americium, that is 5f7, 7s2. Okay. So first one, thorium. Thorium is matching with the electronic configuration, that is 6d2, 7s2, where it is 5f0, 6d2, 7s2. That is our E, option E. Okay, I am writing. One will be matching with 5. Here it is 5, or we can write as in the option it is given as A, B, C, D, A, B, C, D, E. Okay, one will be matching with E. And 2, 5 of 3, 3D, 6D1, 7s2. 5 of 3, 6D1, 7s2, B. Okay, 2 is matching with the B. And the third one, that is 5 of 4, 6D1, 7s2. 5 of 4, 6D1, 7s2, that is D. And the fourth one, that is plutonium, 5 of 6, 7s2. 5 of 6, 7s2. There is no electronic configuration. So promethium is having a property, that is heaviest primordial element, that is plutonium. Okay, that is the heaviest primordial element. Primordial element means the element which is supposed to be existed before the origin of earth. Okay, that is the heaviest primordial element. And then the last one, fifth one, that is relating to, fifth one is relating to 5 of 7, 7s2. 5 of 7, 6d0, 7s2, that is A. So our answer option will be 1E, 2B, 3D. Here it is C, but here it is given as 3D, and 4C, 5A. So answer option is the fourth option. Here also I explained based on the electronic configuration of these elements. Okay, 49th question, answer option is 4. Now, going to the last question, 50th question. The increasing order of basic character of hydroxides of lanthanones in +3 oxidation state is basic character. That is basic character we know. Basic character means the tendency to release the OH minus ions. That is the measure of basic character. All these are having +3 oxidation states. So here the first option is lanthanum hydroxide, cerium hydroxide, then praseodymium hydroxide, then lutetium hydroxide. So here the order of basic character is which one? That is our second option. How it is a second option? Lutetium, promethium, cerium, lanthanum. We know that the largest size is exhibited by lanthanum. Here it is small cation, small anion type, and it is larger cation, smaller anion type. So due to the larger size of lanthanum, it can release OH minus easily in aqueous solutions, and that is how lanthanum hydroxide is becoming the hydroxide having the highest basic character. So these were the questions of today's exam. I think all of you appeared well, and the question was quite easy for you. So hope for the best. Thank you for listening.